Locate the point on the plane x plus y minus z equals 4 that is closest to the point 2, 1, 3. So if you can plug in 2, 1, 3 in here and you get 4, then you're done because it's on the plane, right? Just make sure you understand that. But it doesn't equal 4, does it? So, oh well, darn. But there should be a smallest distance, right, between that point and the point. And there's more than one way to get it, by the way. The way I'm about to show you isn't the only way. So what do we want to minimize here? Something you don't see except kind of inferred. It's inferred, right? You want to minimize distance, don't you? Well, could we minimize squared distance? If you minimize the squared distance, the point that satisfies that will be the same point that's the minimum distance to the plane. Okay, so what is, if we call the square of the distance formula, well, at first it'll be 3 inputs, f of x, y, z. We'll want to get it down to 2 inputs for this to use the technique I'm about to show you here. Distance formula. So the point could be x, y, z, right? So how do you find the distance between x, y, z and 2, 1, 3? Well, the squared distance. So you would say take the difference between the x values, x minus 2, and square them, right? Plus the difference between the y values, y minus 1 squared plus z minus 3 squared, like that. Does that make sense? We'd like to get it down to just a 2-input variable function instead of a 3-input variable function. So if you were going to use Lagrange multipliers, you could just consider this your constraint equation, and then take del f and del g and go from there. But that's not what we're doing. So you guys tell me, how could we maybe get z? What could we use here to get z in terms of x and y? Well, I mean, this equation, right? This equation. So the point x, y, z has to be on the plane, so it has to satisfy that equation. So what we could do then is solve for z, right, in terms of x and y. What would that get us? Z equals x plus y minus 4. Yeah. And then the idea is we could plug that in here for z, and then it becomes a 2-variable function. We'll call it f of x, y. And the first 2 terms don't change. X minus 2 quantity squared plus y minus 1 quantity squared plus, x plus y, and then minus 4 minus 3. What does that get us? Quantity squared. X plus y minus 7, and then you got to square that. So we need to minimize this function. Would you buy that? Does that seem reasonable to you? Okay. Well, what would you do first? I mean, or next. I suppose we've already done the first step. Take the partials, yeah. So what's f sub x? The derivative of f with respect to x? Well, some people want to multiply this out. Don't do that. You can use the power rule, right? 2 times the quantity x minus 2, right? Now there's also an x over here, so we've got this guy, derivative of y minus 1 quantity squared with respect to x is 0. But the derivative of x plus y minus 7 quantity squared with respect to x, what's that? 2 times the quantity x plus y minus 7, right? F sub y. Help me out with that. 2 times y minus 1 plus 2 times x plus y minus 7 again. Okay, and then what do we do with these two guys? All right, so we get a system of equations here. Set this equal to 0. And then Ooh, what's the easiest way to solve that? Okay, it's just a linear system, isn't it? This isn't like the kind of equations you're getting in the next section. If you want, well, I can see a creative way to go. We could eliminate these guys if we wanted to, right? Couldn't we? Yeah, you want to try it that way? I haven't tried it that way, or I don't remember it. Actually, I wrote these problems, but and people think that teachers have the problems memorized. We don't. I don't remember how I solved it the first time. I just play with it every time I redo it. So if I subtract this bottom equation from this top equation, does everybody see what would happen there? So these guys are eliminated. It really is the elimination method, isn't it? Well, okay, I'll do the right side for you. I think it's 0. Isn't that nice of me? I know. Very generous. What do you get on the left side? At least initially. We might want to go ahead and multiply out, right? 2x minus 4, right? And then if we multiply this out, we get 2y minus 2. But then what are we doing with that? We're adding the opposite of it, right? So what would it become? Minus 2y plus 2. Everybody believe that? Well, I mean, that didn't solve all of our problems, did it? But it is a little bit nice. We've got one equation with 2 unknowns. I'm not sure I would do it this way again, because I still need to take one of the equations and simplify it anyway. So I was thinking maybe I would save myself some work, but it didn't end up doing that much for me. That's okay. We can still do it. Divide everything by 2. What do you get? X minus 2. I could have combined those like terms first, too, by the way. Minus y plus 1 equals 0. Or if I combine the like terms in this step and then add to the other side, what do I get? X minus y equals 1. Yeah? Everybody with me? So I tried to get fancy there. It didn't do that much for me because I still have 2 unknowns there, right? But I mean, that is an equation I can use, isn't it? And then I still have to take one of these 2 guys and simplify it to a form that I can use in conjunction with the other equation and then use either the elimination method from algebra or substitution and solve for x and y to get my critical point. That's where we're going with all this, right? We got to get those critical points. So, all right. Let's just for the sake of argument then say you're going to simplify this guy. Multiply everything out. What do you get? 2x minus 4 plus what? 2x plus 2y minus 14 equals 0. Yeah? Okay, and then I will go ahead and combine like terms first here. What do we get? A minus 18 on the end? So an equals 18 if we move that over. So minus 18 from that guy, move it over. And then what else? 4x. And then plus 2y. What happens if I divide out the 2? 2x plus y equals 9. Does everybody believe that? Okay, so combined with this equation then, I've got a nice system of 2 equations, 2 unknowns that I can solve here. How do you want to solve it? I think there's a method kind of staring you in the face, right? Add them up. The y's go away. Yeah? Okay. So we add them up. What do we get? 3x equals 10, or x equals 10/3. Is there a way to get y pretty easily? Which one? I mean, you got many you could plug into. Does it really matter? You could plug into this one, couldn't you? Yeah. So you could take x. Well, x is 10/3, so let's replace x with 10/3 in this equation right here. 10/3 minus y equals 1. So that would mean what? Y equals 10/3 minus 1, right? I move that y to the other side, and then, yeah. And then what would that be? 7/3. So we've got, as a critical point, 10/3, 7/3. Would you buy that? Okay. Do I really need to bother with the second derivative test here? Okay, the plane is going to get as far away. This is common sense, you guys. In this problem, this plane goes, I mean, what is a plane? It's like a tabletop with infinite length, infinite width, but no thickness, right? So any point you can think of, the point of this stylus right here, it's going to have a closest distance, right, to the plane that's the tabletop. But of course, the tabletop goes on forever and ever, that way and that way and that way and that way. So it can get, there's not going to be a maximum distance. Does that make sense? So common sense tells me that this point, this x coordinate and this y coordinate and the corresponding z coordinate on the plane, that's got to be the point. It's got to exist. There's got to be a closest point on the plane that's closest to this guy, this point, which is out in space somewhere, right? So I didn't actually finish. We actually need to find the point in space, and we know what z is. We have it solved for z. So x plus y minus 4 will get me that z coordinate. So what's that? 10/3 plus 7/3 minus 4 is 12/3. So what does that give us? So 17/3 minus 12/3, 5/3. So I guess my claim is 10/3, 7/3, 5/3 is going to be the point on the plane that's closest to the given point. Does that make sense? Does that argument make sense? Does everybody believe that?
Wait, where did the 12/3 come from again?
So it's from the equation of the plane, essentially. This is the equation of the plane solved for z, right? So I just plugged in here.
Oh, okay.
Added those two x coordinates, the x coordinate and those two coordinates, the x and the y coordinate, subtracted 4.